GameSci.com. GameSci.com.
Heidi ho, daddy-o! Welcome to the lesson on Python file I/O. Data in RAM memory is transient. It disappears when the program ends or the computer powers down. Data on the hard disk is persistent. It exists after the program exits or after the computer powers down. Python file I/O. The I/O is input, output. Read and or write data stored in a disk file. Start easy. Let's use functions that read or write in one function call. File object equals open, config.ini, file list equals file object.read lines. What are we doing here? We're going to open and read a file that's sitting on the hard drive. Open and read lines, where each line of the file is assigned to a list slot. Data moves from the disk file to RAM memory. Config.ini must be in the same directory as the Python program. You can see here that we've opened this file and we've read it into RAM memory. Where does it go? It goes into the file list, and each line of the file is assigned a different slot. For one line in file list, let's go access the first line of data from the file. A simple for-in loop through each list element or each line of the file. One line equals file list subscript 0. Basically, this is going to grab the first line or the first slot of the list. There are lots of ways to process data once it's in the list. Remember, a list is just like an array in other programming languages. This is just one way to loop through the data in the file. Into the loop we go. We're going to dump the file contents to the screen. We're just going to say print that line that we read from the file out to the screen. Each print is one line from the file. We've reached the end of the loop. Let's spin back up. For one line equals file list, it'll go to the second element in the list. The color equals blue in slot number 1. Again, this is a simple for-in loop through each list element or the next line of the file, where one line in this case equals file array subscript 1. Note how it automatically advances to the next list slot / line. Print one line, comma, and equals empty double quotes. Dump the file contents to the screen, and there's the color equal blue showing on the output. Each print is one line from the file. Now let me explain the end equals double quote, end of double quote right here. That's so we do not output an extra end-of-line character. Each line of the file already has an end-of-line character, so when we print it, we get an end-of-line character. This suppresses an extra end-of-line character. So instead of 2 end-of-line characters showing up, we only get 1 end-of-line character. Let's end the loop and spin back up. For one line equal file list, we're going to go get slot 2 or subscript 2 of this array, and we're going to assign it to the one line variable. Simple for-in loop through each list element or the next line of the file. In this case, one line will get file list subscript 2. Note how it automatically advances to the next array slot or line. Print one line and again suppress the end of line character. We don't want an extra end of line character. We're already picking one up from each line of the file. And out on the screen goes our res equals 800 by 600. This is just one way to loop through the data in the file. There are many other ways to do it. Some of them we'll look at. It will come back up and try and get the next line. For one line equal file list, but this time it'll evaluate to false because there are no more list entries. It's ran out of data in the list. When the end of list is reached, the for-in loop is false. The loop will now exit. We'll move past the loop to the next non-indented line of code. File object.close. Let's close that file that we opened. This is extremely important. The file must be closed. It will release locks on the file that prevents other programs from using that file. It'll also free operating system resources. There are limits on the number of files you can have open. Always have to close the file to make sure that you don't reach that limit. This open, read or write, and close file is a familiar pattern to people who've programmed in C, PHP, or other programming languages. Open, read or write, and close is how you access a file in many programming languages. Let's look at a second example of reading a file, and we're going to read it all in one line of code. File object 2 equals open user.txt. We'll send it the R flag saying we want to read it. And then we'll say file string equals file object 2.read. So we will open this second file called user.txt. Open for read access. Function read reads the entire contents and assigns the whole thing to a string. This time, instead of loading the data into a list, we'll load the data into one big string. Data moves from the disk file to RAM memory. User.txt must be in the same directory as the Python program. Now, you can put directory information in front of the file name if you want the file in a different directory. But as long as you put just the file name here, it has to be in the same directory as the program. File string equals file string.replace equals 4 with equal 5. Let's replace the equal 4 with the equal 5 in the variable file string. Let's bump the user level here. This is the user.txt file that's tracking where the user is in the game. If they've finished level 4, you want to send them to level 5. There are several ways to code this. You could do an example where you used a Python dictionary. There's just lots of ways to change data once it's in RAM. Note the \n characters from the file will be in file string. If your data file contains \n's at the end of each line, then there will be \n's at the end of each string. Be careful with those. You don't want to disrupt them. File string equals file string.replace the equals 123 with the equals 98. Apparently their score's going down. Let's replace the 123 with a 98 in the variable file string. Let's change the user score. So we've left one line alone and we've changed two values in the file string. Again, there are several ways to code this example. We could have used a Python dictionary. We could have done lots of different commands to change the data. The thing that I'm trying to get through here is when you want to update a file, we typically read it into RAM memory, change the data while it's in RAM memory, and then write it back out to disk. These are two changes we've made to the data while it's in RAM memory. File object 2.close. Let's close the file that we just read into RAM memory. This is extremely important. The file must be closed. This releases locks on the file that prevents other programs from using that file. It also frees operating system resources. There's always a limit on the number of files a program could have open. At this point, we have opened the file, we've read it into RAM memory and changed the data, and now we've closed the file because we're about to update it. With open user.txt, W this time, write mode, as file object. Very interesting. The with as open statement, all file access must occur within the indent after the colon. Everything that's indented after this will operate on this file object. Note the write access, the W there in the open command. It erases the current file contents. It's gone. It's important to have a copy of the data in RAM or that data is lost. You have to be very careful with this W flag because it says, I want to start over. I want to start with a new file. There is an option instead of using W. You could use the A or append access, which does not delete the data. But in this situation, we do have the data in RAM memory, so we're okay with the W access. File object.write the file string. Use the file object created to call the write method to output the changed data from RAM to disk. That must be in the indent. You have to do all the writing within the indent. Note the pending that I put there. The operating system buffers the write until a full sector is flushed. Never count on the data immediately being written out to the disk. Operating systems buffer data. They buffer data when they read it. They buffer data when they write it. We technically have not flushed this data out to the disk drive yet. The indent stops, close is automatic. When the indent stops, we have an extremely important, it runs automatic close. The operating system now will be flushed to the disk on close. The data is now saved on the hard drive. The with as technique for opening a file is better. Only use the plain open when you plan to keep the file open. If I plan to make a quick update or a quick read to the file, I always use with open. However, if I plan to open a file and leave it open and make, multiple changes or over time change several things, then I use open, do my business, and then close it when I'm done with all my changes. So if I'm making short or small number of changes, use the with. If you want to keep the file open for a while, use the open command. To wrap this up, the variable /data created in RAM memory is transient. It disappears when the program ends or power is lost. Data written to disk drive is persistent. It sticks around a day, a week, a year later when programs run to access the data in the files. Python has many ways to open a file. Python has many different ways of closing a file, reading the file, changing the file. I'm showing you the common examples that are kind of consistent across many different programming languages, but don't take anything in this slide as being the only way to do Python file I/O. Sequential file I/O. Functions reading the entire file are for small files only. Large files must be read in pieces because they may be too big to fit in RAM. Code on this slide is similar to code in C, C++, or PHP. The previous examples read the whole file into memory at one time. Well, you're not going to do that with a multi-gigabyte file. This next example is for reading large files a piece at a time. Sequential file I/O. Sequential access files means data is read line by line or block by block to get to the end. You must read every line of data. Data at the start of the file is read before data in the middle of the file, and data in the middle file must be read before you access data at the end. Sequential file I/O means you start at the beginning of the file and you read all the data until you reach the end. File object equals open players.txt with read mode or read access. We're going to go to the hard drive and open this file on disk. The file open function to access the file data. This technically doesn't do the read write. We've declared we're going to read, but this doesn't read any data from the file. What it does is it creates a file object to track the file access or track the file position. If you look closely over here, the file object in RAM memory is tracking, the name of the file, what position in the file we're at. We're currently at the beginning of the file, so it's at byte 0 of the file, and we are open for read access. The file object is tracking what we're doing or what we've read in the file. Now there's several options for access mode. There's R for read access. There's W for write access. Ooh, be careful of W. W wipes out the current contents of the file. There's A for append access. In this example, players.txt must be in the same directory as the Python code. If you don't specify a directory in the file name, it has to be in the same folder or the same directory as the Python program. Let's read a line from the file. There are many ways to read data. I could say line equals file object.readLine. Notice there's no S on this. I'm going to read one line from the file object. Data equals file object.read 1024. I want to read 1024 bytes from a file. There are many different ways to read data. This example is just one way to read data from a Python file. There are several. We've already looked at 2 or 3 different ways at this point. This is a third way. I'm telling you right now, there's a fourth and a fifth and a sixth way to read data from a file. Sequential does not require line-by-line reading of the data. It is reading the file piece by piece until the end of the file or you find your target. Sequential access to the file is starting at the beginning and reading all the data until you reach the end. That's what sequential access means. The reason we need it is because sometimes these files are big and you can't read the whole file in at once, so you read it line by line or piece by piece until you reach the end of the file. That's sequential access. For one line in file object, this is slightly different than we did before. We're going to read each line directly from the file. One line is assigned to the data up to the end of the line or \n character of the file. So what it did is it went and read this first line of the file right here. When it hit a \n, it finishes the read and assigns what it read to the one line variable. \n's are extremely critical for this technique of reading files. Sequential access means file object tracks the first line as read and moves to the second line. Let's use X to indicate the byte number of the file we're currently at. This is file input. Once we've read this first line, think of the read head of the file as being at the start of the second line. And that position X in the file says we've moved down to the second line. JSOB equals JSON.loadS, that one line we just read from the file. JSOB is short for JSON object. Load_s takes a string from the file and creates a JSON dictionary object. What I'm storing on each line of the file is one JSON file string. JSON is not required, but it's easy to change or maintain data that's stored in JSON format. We talked about this on the last slide, right? There are different ways to update the data, and I find JSON/dictionary objects to be a very easy way to update data in a file. So we've took the data that we read from the file and we built a JSON object out of it. Print first colon and then the F entry of the file, a last colon and then the L, and the screen and then the JSOB_s. I have to confess, I ran out of room. I had to abbreviate the keys. I really wanted to use first name or first here, but I ran out of room. I only have so much room on these slides. If I wanted to use good variable names like first name, last name, screen name, I would have run out of room, so I used F for first name. I'm going to use L for last name and S for screen name. So read this as print the first name, print the last name, print the screen name. And you could see the first John, last is Doe, screen is JDog. Typically when I code, I don't like using abbreviated variable names, but in this case, we're going to have to use F for first name, L for last name, and S for screen name. So what did I do here? I opened the file, I read the first line, I loaded it into a dictionary, and I printed it on the screen. First line is down. Let's loop and spin back up and do the next line of the file. For one line in file object, one line is assigned the next sequential line of the file up to the \n on that line. And you can see that one line has got the second line of the file loaded into the variable one line. Sequential access means file object tracks the second line as read and moves to the start of the third line. After I read the line with Sue on it, it reaches the \n, and now my file pointer or my file read head is at the start of the third line. Look how we use Y to indicate the current position in the file. One of the primary jobs of the file object is to keep track of where in the file we're at. We have read two lines, so this position Y indicates that we are at the start of the third line of the file at this point. JSOB equals JSON.loadS one line. Take that one line of data that we read from the file, load it into a Python dictionary. You do not have to store your data in JSON format in the file, but if you do, it's the easiest way to change it. JSOB is short for JSON object. Load_s takes the string from the file and creates a JSON dictionary object. JSON is not required. Another popular format is called the CSV, or comma separated value format, where the data is separated by commas. And sometimes we store files in that comma separated format. Sometimes we don't. The older I get, the wiser I get. I tend to want to store my data in a dictionary format as opposed to a comma separated format. Comma separated format has a little more work to update and change the data, but it is an option. File formats are a dime a dozen. There are dozens of different ways you can store data in a file. Storing each line as a JSON string is just one way to do it. So let's use our JSON object or our dictionary to print out the first name, the last name, and the screen name of the user being stored in the file. And you could see, boom, the data comes out on my output screen. Sorry, once again, I apologize. I just ran out of room. F is basically shorthand for first name. L is shorthand for the last name. And S is shorthand for the screen name. You know, this may be a list of users in my online game, and normally I'd use first name, last name, and screen name, but I ran out of room. After the print is done, we are hit the end of the loop, and we will spin back up to our for loop. For one line in file object, we will read the third line of data from the file. Boom, there it is. This data on the third line was read into RAM memory. One line is assigned the next sequential line up to and including the \n. Sequential access means file object tracks the third line is read and moves to the start of the fourth line. But watch out, there's a couple question marks there. Well, use Z to indicate the current position of the file. So we've read this third line up to the \n, and we are technically now here at the start of the fourth line, but let's be careful. We're going to talk about that very shortly, what goes on there. JSOB equals JSON.loadS one line. Take that one line of data from the file and build a Python dictionary out of it. JSOB is short for JSON object. LoadS takes a string from the file and creates a JSON dictionary object. JSON is not required. Another good format is called fixed length fields, where Sue gets a certain number of bytes to be stored in, and Kim gets a fixed number of bytes, and screen name gets a fixed number of bytes. Again, I will stress, storing each line of the file as a JSON string is just one option. Some people use comma separated value format. Some use fixed length record format. There are several ways to store data into a file. This is just one example. Print the data. Print the first name, the last name, and the screen name to the out. Once again, I apologize. I don't like abbreviations like F, L, and S. Excuse me, I didn't have room on this screen. It's already a busy screen. I didn't have room on this screen for first name, last name, and screen name. Now we've hit the end of the loop, spin back up, and some interesting things are going to happen this time. For one line in file object, and look what it hit. It hit what's called EOF. We've reached the point where there is no more data in the file. End of file is reached will return false when there's no data left in the file to read, and it ends the for in loop. File object tracks where the file pointer is, and right now the file pointer is at the end of the file. And you can see I'm at byte end of file. That means there's nothing left to assign to one line. That means this loop is false and it will exit the loop. File object.close. This is extremely important to close the file. And you can see my file object is now marked as closed because we reached the end of file. Do you see the sequential access? What I did here is I started at the beginning and I read one line and then the next line and then the next line, and I read every line until I reached the end of the file. Start at the beginning and read until you reach the end. You don't have to do this line by line. You could do it block by block. Sequential access simply implies you start at the beginning and you read everything until you reach the end. And finally, when is sequential file access required? When the file is too big to fit into RAM memory. Let's do another example. With open players.txt, append mode as file object. This is new and this is different. File open with append mode this time. Notice how we're at the end of the file and we are in append mode. We're going to add data to this file, so we're going to keep the current contents of the file. The A here on the open is much safer than the W. Remember, if we put a W here, it wipes out all the data currently in the file. Append mode says jump to the end of the file right here and add new data to the file. If you look closely at the arrows, the file pointer is at the end of the file, so the next write will keep the current data and add new data to the file. JSON object equals FK L Fox S Foxy. We're going to create a new JSON dictionary object to add to the current data of the file. This is a JSON dictionary in RAM memory. JSON string equals JSON.dumpS JSON object. Convert the JSON object dictionary object to a plain string. Text files require you to write plain text to the file, and what we're doing is we're creating a JSON format string object in order to write it to the file. File object.write JSON string plus \n. Write the new data to the file. The call to write to output the JSON format string to the file. Notice how we add a \n so the file can be viewed with a text editor, and the file can be read line by line. The write to disk does not complete until a flush or close executes. So this is almost more like an appending write. I'm going to add new data to the file, and when we close this file, it'll get flushed out to the disk file. JSON object equals FJ L Toms S Jacks. Create a brand new JSON dictionary object to add to the current data of the file. JSON string equals JSON.dumpS JSON object. Let's convert the JSON dictionary object to a plain string. Text files require you to write plain text to the file. All I'm doing is making a text string that I can output to the file. File object.write the JSON string plus a \n. Let's call write to output the JSON format string to the file, and you can see the new string shows up at the end of the file. We're going to add a \n so the file can be viewed with a text editor and the file can be read line by line. Recall the previous example right up here where we read the data file by line. We got to make sure there's a \n at the end of every record in this file. The write to disk does not complete until a flush or a close execute. I drew these in red because they are pending writes to the disk file. The operating system always buffers input and output. When you're reading a file, it reads in a whole block of data at a time. When you write a file, it waits till it has a full block of data to write. So I'm never quite sure or never positive that the data is on the disk drive until I flush it or close the file. Bang, we hit the end of the indent. So the extremely important close is called automatically when the indent ends and the new data is now flushed to disk. Now I'm certain my 2 records are on the hard disk drive. There's no guarantee the data is written to disk until a close or a flush executes. Remember, all file I/O is buffered by the operating system. The output to the disk happens when you flush the buffer or close the file. That wraps up this slide on sequential file access. Again, this is files that we're going to start at the beginning and read all the data through to the end. Random access files. Sequential access is not good when you only need to access a small amount of data in a large file. No one wants to read 500 megabytes of data to get one record. Random access allows a program to jump anywhere in the file to read and write data. So instead of going line by line, I'm going to jump straight to kfox and read kfox directly. Random access requires a fixed length record, where each line/record contains exactly the same number of characters or bytes. Now I chose 50 here, that's kind of arbitrary. The program designer decides how big each record could be. This could be 128 bytes, this could be 256 bytes. I chose 50. The \n that I'm showing here at the end of each line in the file is optional. I like it so the file can be used with a text editor. When you add \n's to these files, you can load it up into a text editor and see what's in the file. With open dbase.db in append mode as file object, I'm going to open this file on the disk drive and create a file object to track where I am in the file. File open function to access the file data. File object, again, is tracking what I'm doing in the file plus where I'm located currently in the file. The append access is important. We want to be at the end of the file right now, and for sure, don't use W mode. W mode wipes out the current data in the file. Since we are going to read and write from this file, we certainly want to keep the current data in the file. dbase.db is in the same directory as the Python code. If you want, you could put a directory in front of the file name, and this file could be in a different directory. With no directory name, you have to be in the same folder as your Python program. Size equals 50, rec number equals 3, or record number equals 3. 50 is the length of each line, and 3 means we want to go to record number 3. These are fixed length records where each line of the file contains exactly 50 bytes. Each line of the record is 50 characters, so record 0 would be at byte 0 or position 0 of the file. Record 1 would be at byte or character 50 of the file. Record 2 would be at byte 100. And record 3, which is the one we're going to access, would be at byte or character 150. If each line is exactly 50 characters, then I know exactly where each record starts. Record 4 is at byte 200. This way, it's easy to calculate where a record number is located. If I want to go to record 2, I go to byte 100. If I want to go to record 0, I go to byte 0. FileObject.seek, record number times size. The fileSeek function moves the file pointer to 3 times 50 or byte 150. In other words, record 3. Take a look at this. If I go to byte 150, I'm moving the read head of the file right to that K in kfox. And notice how the file object says move to position 150 of the file. That's what the seek does. It says seek to a very specific position in the file, so the next read will start at that position. This is the random access. Move to any location in the file without reading the data prior to it. A fixed length record is required. We just did sequential access. To get to this record in sequential access, you have to read every line of this file to get to kfox. Random access said just jump to this position without reading the previous data. Record equals fileObject.read size, which is exactly 50 bytes of data. I'm going to read exactly 50 bytes all the way to and including the \n and store it in my record variable. The file read function reads exactly 50 bytes / characters from file object or dbase.db and assigns it to the variable record. Look at the byte 200. The file pointer advances. If I seek to position 150, read 50 bytes, then I am now at position 200 in the file, and you can see that's what the file object is tracking. This is a database record, a set of fields describing one player / users in an online video game, and I just read one record in RAM memory without having to read the previous records in the file. That's what the seek function does. It says jump to a specific position in the file. Print record number 3 before and then the output of the variable record. Let's print the record we just read from the file, and there it is, record number 3. Before I did anything to this file is kfox foxy, and there is its output. Record equals record.replace K with Bob. Record equals record.replace Fox with Box. read data from disk to RAM, and then update the data in RAM. We saw this on a previous slide. You've got to get that data into RAM memory, then you can change it. This is a fast and easy way to change RAM. Warning, do not change the record size. You have to be very, very careful. I made sure I replaced 3 letters with 3 letters and 3 letters with 3 letters. If you are doing fixed length records, you've got to keep each record at exactly 50 bytes. This is a very simple update. You could have done a much better job of this. Once again, I can't show you every way to change data in RAM memory, so I just said, hey, replace some letters here. But the thing I made most careful of is I did not mess with the record size. I kept it at 50 bytes exactly. FileObject.seek record number times size. I'm going back to position 150 in the file. The fileSeek function will move the file pointer to 3 times 50 or byte 150. In other words, the start of record 3. Notice the update to 150 here. To replace a record, you must back up to the start of that record. The intention of this example is to replace this record, to change the names on this record. So I read byte 150. To replace record 3, I have to move to position 150 of the file. FileObject.write my record. FileWrite function says write 50 bytes / characters from the RAM record to the disk file object dbase.db. Warning, record size must be exactly 50 bytes. Look at byte 200, the file pointer advances. If I go to byte 150, then write 50 bytes, my file position should be byte 200. This is extremely important for random access. The record size has to be fixed. So what I just did is I updated a database record to the disk. I'll put my little pending warning because I've warned you before that writes to disk drive don't usually happen until you flush the operating system buffer or close the file. So for now, let's say we are pending a write to the disk drive. Print record number 3 after and print the record we just wrote to the file. I did not do it, but we should do a little more error checking on this slide. Not enough room on this slide to do it, but there are several different checks I could have added to this slide. I could have done an ospath.exist to the file before I opened it. I could have done an if statement after this write to make sure it actually did write. Please, when you can, do error checking. But here's the record before I changed it, and now here's the record after I changed it. Bang! Indent stops, close is automatic. With the with open command, it will automatically call close. Now the file close function notifies the OS to flush pending writes to disk. Now I'm certain the data is on the disk drive. Now I changed it to bold black text to show you, yeah, this thing is now on the drive for sure. This is extremely important. Close is 100% required. I'm never certain my data has been updated on the disk file until I do a flush or a close on the file. Now what we've been doing here is sort of an open read-write close pattern that is typical with a lot of languages like C and C++. The pattern is this: you open the file, you read or write the file, and then you close the file. File updates follow this consistent pattern. We read data into the RAM, we update the data in RAM, and then we write the data back to the disk. And always keep in mind that operating systems buffer updates until a flush or a close of the file occurs. If, for example, a program might crash in between the write and the close of the file, you could lose those file updates. In summary, we have covered 3 techniques for file I/O. Number 1, we looked at the Python functions that read and write an entire file all in once. This is for small files that will easily fit into RAM memory. Number 2, we looked at sequential access using the open read write close pattern. This is where you open the file and you read all the data from beginning to end because maybe the file's too large to fit in RAM memory. And finally, the third technique was random access. Seek to a location in the file and read and write. No need to read all the data in the file. Again, if you're working with a large file, it takes a long time to read all the data. Random access is much faster when you can jump to a certain position, read and/or update a record, and then be done with it. My final summary before I close this lecture out is this is just a few of the techniques in Python. There's many different ways to read and write files in Python. I do try to show it to you in the most generic way, the way that a lot of different languages do it. So that wraps it up. Have a good day. See you on the next lesson.